All right, so here's a video on graphing the tangent function, and I went ahead and put the unit circle over here and archived 2 points over here. Now, the issue is you can't just read tangent off the unit circle. You have to do a little math, so it's, your sine divided by your cosine, so 0 divided by 1, 1 divided by 0, sine divided by cosine over there, and same thing there, and we're back to where we start from, right there. And so, unfortunately, this isn't super useful. It does give me that this is 0, this is undefined, this is 0, this is undefined, and this is 0. So I do at least know where my asymptotes are. So right here would be an asymptote, and right here. But to graph it accurately, I don't, other than points at 0, I have no idea what this graph looks like. So it's nice to think about your 45s in here, because with tangent, you take sine divided by cosine. So square root of 2 over 2 divided by square root of 2 over 2, positive or negatives. You're going to get some ones and negative ones, which is kind of what we're used to with sine and cosine functions. So that seems a wise idea. So instead of having this minimalistic key points, which we're kind of used to, we are going to add some. So we're going to go every pi over 4. And again, you can either write 2 pi over 4 if that, if you want, or pi over 2. We're just going to insert the pi over 4s in here. So I'm just going to count by pi over 4s just to make life easier, so you can see that I have a consistent unit. And when we graph, and again, this is to help you, so it really doesn't matter to me what you write there. But is everyone okay? That's 0 to 2 pi. All right, so from before, I know this guy's 0. At pi over 2, which is this when it reduces, is undefined. This one is pi when it reduces, that's 0. This guy's 3 pi over 2 when he reduces, that's undefined. And this is 2 pi, which is 0. That's what I have from this over here. But now I'm going to do these. Well, this is going to be square root of 2 over 2 divided by square root of 2 over 2. That's 1. This is also going to be 1, but it's going to be negative because my x value is negative, my y is positive. This would be negative square root of 2 over 2 divided by negative square root of 2 over 2. So that's tangent's positive there. And then over here, I'm also going to get a negative because my y value is negative. My x is positive, but my y is negative. All right, so now this gives me a little bit more to graph. All right, so this helps me quite a bit, actually. So I'm just going to go ahead and do this. My units are pi over 4. Let's see if I can make them small enough to fit here. Yeah, let me erase that. Sorry about that. Let's try again. And again, not that I can't graph on the negative side, because I can. So we'll go there, and then let me get a little smaller here. So we'll go here. Again, each of these is going to be worth pi over 4. So like that's pi over 4. Oopsie, sorry, pi over 4. This would be pi over 2. Right, this would be 3 pi over 4. And this would be pi. All right, so again, you can label your units. This would be negative pi over 4. All right, so I could go ahead and label those. Now, I'm going to have 1 up here and negative 1 here. All right, and I'm going to switch to red to graph this. So I have 0, 0, and I need a much smaller thing. At pi over 4, I'm up at 1. At pi over 2, I'm undefined. And where's my next undefined? At what, 3 pi? So we can get there. All right, now if I went back, this would be negative. So this is going to kind of come like that. There'll be another asymptote over here. All right, so let's look at the next one. 3 pi over 4 is a negative 1. So it did that. Pi is at 0. And notice this is 5 pi over 4. So that's going to be up at 1. So if you're like, how did you know that shape? Well, maybe it's because, there we go. All right. And again, our asymptote, so here's what, 4 pi over 4. This is 5 pi over 4. This is my 6 pi over 4. Again, that's my asymptote. It's going to be undefined right there. All right, so let's see, 4 pi, 5 pi, 6 pi, pi. I should just label these guys to make life easier for all of us. So this would be, what, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. And again, you could reduce those. Alright, so then my next one is what at 7 pi is a negative. Oops, sorry, got over. It's late at night, so my brain is not as sharp. Alright, so 7 pi over 4, negative 1. This guy, which reduces, and obviously you can see the pattern, so this guy's going to go up at 1, and then I'm going to have another asymptote at the next unit. And again, this gets really close, and it bends and can go like that. So should be, might have been very good, but should be a nice little bend there. And that would be the graph of a tangent function. As far as domain and range, we better do that quick before we switch to videos, but the domain is going to be all reals except x where, let's see, what can't x equal. So we have issues. Our first issue is at pi over 2. And then after that it goes every pi, every pi, every pi. So there's another one. So every time I add a pi to it or subtract a pi to it, I'm going to have problems. So we're going to call that k pi. And again, k is an integer. My range starts down here, goes forever. So that's negative infinity to infinity. So that's actually all real. So that's going to be fine. And my period, if you look right here, is just pi. So let me write that up there. The period is actually pi, so that's different. So that's something worth noting. Cosine and sine is 2 pi, tangent is pi.